All right, we are going to go through the 4.3 notes proving triangles congruent by side, side, side. What we're going to do today is I'm going to show you, you're actually going to go to a website and figure out if this really does work. But if there is a shortcut for proving triangles congruent, ideally we don't have to prove all the angles and all the sides. If possible, we want to use a shortcut. So we're going to try that here. First, before we do that, we are going to think about why triangles are significant, why are they important. If you look at these shapes, here we have some kind of square, here we have some kind of, I don't know, really two triangles put together, and here we actually have a triangle plus some kind of rectangle-ish kind of thing. And which one of those would be the strongest? If you pushed on it, it would not change its shape at all. And so we are going to figure out, or just think about, I guess, what makes them stable. And there's all kinds of things to think about. Does it matter if they have more corners? Does it matter if they have more sides in them? Does it matter if they have different kinds of shapes? And it turns out if on this first shape you pushed right here, this button right here would actually slide a little bit, and you would end up moving it like that without changing any of the sides. You could push even more, and it would keep sliding over. So it turns out that this one is actually not very stable at all. And then it turns out on this one over here for letter C, if we were to look at letter C right here, we actually could take this button right here, this one right here, and if I pulled it out a little bit, that would actually expand that a little bit, and again, this one would move. So it turns out that one is not stable. The nice thing about triangles is when you have a triangle inside here, it is not really possible to move those, because if I wanted to move this button right here, the only way I could do it would be to shorten this side, and it's already locked in, so you can't do it. So the thing that makes something stable are triangles. Triangles make shapes stable. So if we look down here at these football players, we notice that they're sitting on two benches, and if we look real closely, we see that this first bench is a rectangle, but it does have a brace that goes right down here. And if I look at that real closely, I actually notice that I have two triangles inside that brace, right here and right here. But if I look at the other triangle, the other bench, I notice that it's made up of just a rectangle, no brace at all. So if these guys started to slide a little bit to the right, that would take this whole shape and it actually would start sliding this way, and those guys would end up crashing to the ground. We'd end up with one big long bench on the ground. And so those two shapes are not stable at all. If you go a little bit lower on your first page, we are just looking here, we're reviewing our corresponding parts, and remember the corresponding parts are the parts that are named here in your congruence statement, and remember that everything is lined up and ordered exactly the right way. It says name the congruent parts in the two triangles. If I look at these, angle X, according to my congruence statement, would be the exact same as angle M. And I could go all the way around. Angle Y would be the exact same as angle N. And the last guy right here, angle Z, is congruent to angle L. And for that matter, we could use all of the sides also. I could use the first two sides, XY with MN. XY congruent to MN. I could do the next two, YZ with NL. Bars above the top. And I could do the last two, I could do XZ congruent to ML. And then it says, what measurements do you know? So then we can go back and look here. Angle X we said was the same as angle M. So I can take this 33-degree angle that I have right here and put it over here at 33. I also notice that I have 124 at angle N. So I look over here and it says angle N is the same as angle Y. So I can fill in a 124 right there. And then the last thing is I don't actually know a number for L and Z, the two that are left, but the third angle theorem says they have to be the same. And I do know that there are 180 degrees in a triangle, and if I take away the 124 and the 33, which is a total of 157, I would have a total of 23 degrees left. That makes both of these angles 23 degrees. The last thing that I know is that I have this side over here, NM, and I look over in my congruent statement and it says that NM is the same as XY. So right here, this XY, I know that I can put an 8 on there. The other two sides, we don't have any information, so we can't add anything to those. The last part that we're going to talk about here on this page is just a review here, quick corresponding parts. Those are the congruent parts, just like we talked about above right there. And then the question says, how many angles and sides do triangles have? And remember, they have 3 angles and 3 pairs of sides. So when I do corresponding parts, there will be 6 parts altogether. 3 angles and 3 side pairs. All right, we're going to stop the video right here. And you are going to go to, flip over to page 2. And you're also going to go to Schoology and look at the activity link. And I will help you through that.